Good afternoon, I'm Peter Lindes from CIC, and what I'm going to talk about relates to what you've already been hearing in this last session. But I'm going to try to talk a little bit about a vision of where I think it would be like to be able to go. Because imagine you could just say to your agent, Alexa, do the dishes, and it would actually go physically do it. And even a larger problem, if we want to have Soar learn how to make breakfast, which actually John had been already doing, but it wasn't learning it from interaction yet. And that's maybe a small part of an even larger problem, which is how can we build robots that use natural language to collaborate with humans in the real world? And so I'm going to show you some ideas about this, and I want to mention my friend Karl Torskiefer, who has helped me develop some of these ideas. So there are a lot of companies out there building robot assistants in the world. This is a robot that works in a hospital. It's assistant to nurses and delivers things from here and there, here and there, and it can even push an elevator button and go up and down floors and stuff like that. Texas Instruments uses a lot of robots in their semiconductor manufacturing, and they actually build robots and robot components. And they talk a lot about how we now have robots that are safe to work right next to human beings. They don't have to be in a cage somewhere where humans never go. Another kind of robot assistant is just kind of a companion. And these are not very sophisticated so far. They just sort of can have some simple conversations. But imagine if someone who had limited physical capabilities could have an agent that would help by doing household tasks, making meals and things of that sort. There's another company that builds robot kitchens. And this is a robot you can have in your kitchen in your home. And it knows a whole lot of recipes, famous international chefs, and it can make all these recipes for you. So that's pretty cool. But there's some fundamental limitations to almost all of these robot assistants. First of all, their ability to really interact with you using natural language. Like that robot kitchen there, I don't think there's any way you can teach it to do a recipe that's your own recipe that you want it to be able to do. And also their ability to learn and reason about large complex bodies of knowledge is also limited. So if we want to have robot assistants that can use language, it seems to me it's useful to think about, imagine if you were to hire a human to be your full-time cook in your kitchen, and they maybe went to culinary school, so they came with some knowledge of cooking, but you took some time to train them about where you store things in your kitchen, what kind of recipes you like, or your members of the family, what your schedule for meals are, things like that. But then that cook quits, goes somewhere else, and you think, well, maybe I can replace him with a robot. What would we need to build a robot that would begin to approximate what that human cook could do? Well, I think there are a lot of hard problems in building such a thing. And a lot of them are the robotics level of vision and manipulation and navigation and so on. But what I want to talk about more is the hard problems that have to do with knowledge and reasoning and with language understanding. And, we've done a lot of things with ITL in the past that are, impressive, but their language capabilities are very limited still until the kinds of things that James has been starting to do. And also the range of knowledge they can deal with is also somewhat limited. And there are these agentic LLM systems that I don't think are really adequately grounded to the real world, and they have some reasoning capability, but I'm not sure it's enough. So let's look at how we might go about doing this kind of thing. So imagine, here's our kitchen, here's our AI to Thor kitchen again. So imagine that you had your human cook there first, and you had this conversation with them. You come in the morning and say, I'm hungry, what's for breakfast? Oh, well, what do you want today? How about some toast and an omelet? Okay, and I know you like butter and jam on your toast, right? Oh yeah, that sounds good. And the robot the cook already knows that when you want an omelet, you like to have cheddar cheese in there, but there's no cheddar cheese in the fridge. So it says, oh, we're out of cheddar cheese. Can we use Swiss cheese instead? Well, I guess that'll do. But be sure you order some cheddar. And so the food just goes in, make their whole breakfast. They serve it to you, you sit down and eat. Here's your breakfast. And while you're eating, the cook cleans up the kitchen and orders the cheddar cheese. So what kinds of tasks is this human cook able to do? Prepare and serve meals, clean up afterwards, maintain an inventory of all the different kinds of ingredients and so on, and be able to do things like making a shopping list, ordering groceries online, and storing the groceries when they're delivered. And what are some of the kinds of knowledge it needs to have to be able to do all those tasks? It needs to know the layout of the kitchen, where things are normally stored, what are all the some of the kinds of ingredients, what are different recipes that you like, what are the tools that you use, ways to clean up, personal preferences of the humans involved, what the current inventory is, and ways to order new things. So that's a lot of different kinds of knowledge we have to learn. So how could we make a system that would do that? Well, here's kind of a block diagram. And first of all, there's the human who's going to provide overall direction and a lot of knowledge, especially specific situational knowledge, through interaction with the agent. We have the physical robot that knows how to perceive things in the world and knows how to physically act in the world. We have this body of situational knowledge that we're going to be learning over time that knows a lot about the physical situation, human preferences, the different kinds of tasks, and so on. Then we have the large language model, which has, I think, two primary functions in this overall system. One is translating the language that humans just normally use in their everyday conversation into a form like James's hierarchical logic graph that the Soar agent could understand. And also it can provide different kinds of general knowledge. And at the center of all this is this cognitive agent, or Soar, that's integrating all these things together to make an overall functioning system. And I think our research group, basically we have some experience in all of these areas, and we're in the process of trying to see how we might put them all together. So as I've been thinking about this problem, I think there are really sort of three dimensions to the problem. The first is taking this kind of free-form language that humans naturally use and making it understandable to the agent. And James just talked about some progress in that direction. The second one is using interaction to learn all this complex knowledge that the agent needs to learn. And Aaron has talked about parts of that problem. And the third problem that also Aaron talked about a little bit is about how we generalize this information. Because when you teach something on a particular situation and a particular object, that may or may not be generalized in different situations. And I'm going to talk about more details of these different things. Here's an example of some natural language. And this actually is also an example of getting general knowledge from a large language model. So I asked ChatGPT recently, how do I make scrambled eggs? And it gave me this great big recipe. And this recipe, I think, would be easy for a human cook to understand, or a human cook might have written it, or I could have gotten it from a cookbook somewhere. But what does our agent need to understand? It needs to be able to understand how to name all these different kinds of ingredients and also how to measure them. And it needs to understand all these different things like cracking eggs and taking a pinch of salt and so on. And the different manners like cooking gently. And it needs to know the criteria for when a certain action is finished. Like when something is fully combined, or it has a creamier texture, or we've got the pan coated on the bottom. Those are going to involve a lot of perceptual problems, as well as language problems. And so, but the problem I'm really interested in focusing on is how do we translate this sort of language into some kind of representation that Soar or a Soar agent could work with. And probably that's going to involve human interaction as well in order to provide some kinds of detailed explanations or some of the grounding information. And also, important part of the human in the whole system is to help verify that the answers we get back from a large language model are really correct and valid. So there are a number of issues involved in grounding natural language to the physical world. Some have to do with all the kinds of non-standard language that humans use. And some aspects of that is there are many different ways to talk about the same thing. And especially like object references, I'm going to show some examples in a minute. There's a lot of different ways you can, in language, refer to the same object. Verbs can have a whole lot of different meanings depending on what object they apply to and other aspects of the context. You have to sometimes deal with abstract concepts, and individual humans have different ways of talking about things. So here's an example of, these are snippets of language that were generated by Amazon Turk people. There's a database called Alfred that has humans trying to teach, watching a video and then trying to explain to a robot how to perform that task. And each one of these boxes here is different ways of referring to the same object in the same scene. And sometimes it's the same person at different times, and sometimes it's through each one of these tasks has 3 different people. So you see a lot of different variations here. And how are we going to ground all these different kinds of things? And there are a number of different ways of using language to ground objects, but I want to look at just a couple in particular. Spatial relations can be very complicated, like the knife between the lettuce and the apple. That's not going to be something that can be pre-computed because there's so many, possible options of that kind of way of talking about things. So it's going to have to be computed, and the degree, James had the large language model grounding things based on the categories of objects, but when you have these kind of complex things, I'm not sure how far the language model can go, but that's something we can experiment with. And also some things like the counter left of the bread. Well, the bread is at a certain place now, but when John's agent comes along and slices the bread and makes toast, the bread might not be there anymore. So, it's things that are time variable. Another kind of thing is what I've been calling discourse properties that have to do sort of the history of the agent. And there's several different kinds of things here. The one that says the knife used to cut the potato. So you have to know that sometime previously, I picked up a knife and I cut the potato with it. And now who knows where I left that knife, and I've been doing some other things in between, but I've got to remember that. So that could be based on either a history of the dialogue that we could send to the language model, or it could be done from source episodic memory. And some others, like a slice of the cut potatoes, again, past history. Or the cooked potato is the potato that we already cooked. And some other things are more about the current state, like the counter with the blue plate on it. So that has to do with, again, with resolving a spatial relation and seeing where things are right now, or the kitchen counter with the loaf of bread is a similar thing. But then when you're talking about goals, put a cooked potato slice on the counter, that's talking about a future state, which is like the hypothetical things that John talked about grounding. So over the course of a discourse, there are things about the past, there are things about the present, and there are things about the future. We need to learn how to ground all of those. In terms of the variation with verbs, a verb I've been thinking about a lot is the verb cook. And here, each one of these sentences is pretty simple. It's a verb with an object, or in one case, an additional prepositional phrase. All those verbs in the proper context could be more or less synonyms of the verb cook. But exactly what they mean is very different. Like cooking potato in the microwave, we've seen some videos of that, it's just puts the potato in the microwave, closes the microwave, turns it on. But make breakfast is a much more complicated task that involves a whole lot more knowledge of a lot of different things, or prepare dinner for the family, or even fix an omelet or cook eggs benedict. Those are all much more complicated kinds of tasks. And so in order to interpret the verb cook, you need a lot of different kinds of information about the overall context, about who's eating what and what's happening, how we want to present and serve things, how we want to clean up. And also different kinds of entities have different kinds of results. Are we just cooking a particular item? Or are we cooking a dish like scrambled eggs that involves a bunch of ingredients and so on? Or a whole meal that would involve multiple dishes? So the verbs in context mean a lot of different things, and there's a lot of learning that's going to be involved in trying to gather all the knowledge of this sort. So here on the left, here's this dialogue that I showed earlier about talking with your human cook about making breakfast. And I think to really get to that point, there are a lot of challenges, but it's because about free-form language and how we get the agent to learn all this situational knowledge. One way of sort of partitioning the problem is, let's say, suppose we translate that dialogue into much simpler language than our current parser that we have in Soar might be able to understand. And here's an example of a somewhat simplified version of that breakfast dialogue, where you just say, make breakfast, and you want the regular thing. And so the language is very simple, like make my breakfast. It's these simple verb object kinds of sentences. And in that case, we have much more constrained knowledge, but we have a lot of, in order to be able to perform that dialogue, that has to have learned all this situational knowledge. So I think we can sort of partition the research problem of how we gather the knowledge from the research question of how we translate the language. So making breakfast is going to have a lot of subtasks, as I've listed here. And so we're going to, if we're going to use some kind of interactive task learning, including interaction with the language model, we need to have some kind of dialogues that we're going to use to learn all these different parts. Each one of these subtasks is going to have a lot more subtasks underneath it. We need to figure out ways of representing knowledge about where things are in the kitchen, how you order more eggs or more cheddar cheese, and how to do incremental generalization. I'm going to give some examples in a minute. And also another issue, looking at this diagram, you might think, well, these are subtasks, so I'm just going to do one after another. But actually, to do things efficiently, as some of John's presentation shows, we probably want to be able to interleave different parts and different subtasks. And so we need to be able to handle that. So I'm going to go down now to more specific things about what we're trying to look at. This is an example that Aaron put together the other day about how to learn open. Suppose you don't know an action model for the verb open. So what do you need to know? You need to know its preconditions. So it asks about that, and we get a set of goals, and then we need to know what the result of this is going to be, what the effect is, that the fridge is open. We also need to know the name of how this English verb translates to whatever the name of the command that you actually give to the physical robot. So this is kind of an example for how we learn at a low level, and then hopefully we can build up more and more to these larger tasks. And I've been thinking about this generalization problem, or at least one aspect of it. So if we teach open the fridge, and the fridge is reachable, and you're not holding anything, okay, so that's what we need to open the fridge. But now we want to open the microwave. And I think John mentioned something about you can't open, or John already had that in his preconditions, that you can't open it if it's already turned on. But when we learn to open the fridge, that didn't matter for the fridge, so we didn't learn that piece of information. So if we, there's a piece of the action model when we apply it to a microwave that we haven't learned yet. And another example, we've also talked about discarding the apple. Well, the apple's in the garbage can, but suppose instead of that you want to discard it, empty soda can, that should go into the recycling bin. So these are examples where if we just have this one specific dialogue, we try to generalize it too much, that's been mentioned before, we need to figure out how we're going to deal with that. And should we have multiple action models that are where you choose the action model depending on what kind of object you're working with? Or should we have a single action model that has various parameters with it? And then suppose we learn this action model, then we learn a chunk, and then we find out, whoops, that action model is not general enough. I need to change it a little bit. Right now, this Soar architecture doesn't have a very good way of forgetting a chunk. We need to, that's an issue we're going to need to deal with at some point. So what are some nuggets? I don't know. I just love the idea that we'll be able to, buy this robot from Amazon and it's going to be able to do all these things in the kitchen. I can give it to my wife and she can teach it all these things. And I think Soar really has all these kinds of capabilities, especially when we combine it with a large language model, that can really make a major contribution to getting real robotic assistants that do things with using natural language in the real world. But the main goals are that there are a lot of significant research challenges yet to accomplish that, to making the language understandable, to coordinating ITL stuff with learning from the language model. How do we coordinate all that to get all this situational knowledge? And how do we solve these problems about grounding in the physical world? But I think we can still imagine a future where we can say, Alexa, do the dishes, and it'll actually happen. Thanks.